Hi.
Hello.
Hi.
Hey, good evening.
Everybody's so serious looking.
Where are we? Yeah. Okay. Good evening, everybody. Happy Father's Day to all the dads out there. First of all, hey. My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. Also an amateur astronomer, member of the Royal Astronomical Society of Canada. But first, I wanted to say welcome to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. Yay! Yay! Yay!
Yay.
Yay!
All right, just kidding. Now I'm good.
Good. Okay. Anyway, lively bunch, yeah. First of all, I'd like to introduce my two regular co-hosts for this evening. Anyway, I'll be really excited about this. Mr. Mike Powell from the PFO Observatory here in St. John. Hey, Mike.
Hey.
Oh. And Mr. Paul Owen from the Moonshot Observatory in Hampton. Hey, Paul.
Hello.
Oh. And we'd like to welcome all of you from Facebook and YouTube land. YouTube and Facebook land, whatever. Thank you so much for your support. Okay, on tonight's episode of the Sunday Night Astronomy Show. Now, there is a growing interest in smart telescopes. A smart telescope is a type of telescope designed for ease of use, especially for beginners. Now, it features a built-in camera, a motorized computer-controlled mount, and is operated wirelessly via a smartphone app. Get to page 2 here. Okay. The app displays live images from the telescope's camera and allows for storing and sharing photos of the night sky. Now, they also have been proven valuable when offering astronomy outreach, especially in locations that have too much light pollution. Tonight, we invite back our friend and local astronomer, Mr. Robert Gaudet, to help us understand the operation and advantages of a smart telescope, the SeeStar. That's one of the several types available. Robert will also be presenting a collection of his own captures using the SeeStar telescope. And welcome back to the program, Robert.
Thanks so much, guys.
Good to have you here.
Yes, sir.
Okay, so the goal tonight basically
hang on now.
is
Gotta finish up.
Yeah, go ahead.
Let me do my part.
Sorry.
I don't want to have to mute you.
Okay.
Anyway, also tonight, Final Bed will be returning with another fine binocular target of the week. We'll have another interesting Rosanna's fun fact.
Yes.
And I will give a brief overview of what's up this week, just very brief, along with your wonderful photo submissions. So then, now we can get started with a discussion around new smart telescopes.
Okay.
Robert,
All set? All right.
yes, sir.
So the goal tonight is basically just to give an introduction as to what it is, what it can do, the new features that have come out since the last time I get the presentation, and just a little bit of my gallery and what you'll see, what processed versus unprocessed looks like. And I'll see if I can get let's get this going here and share my screen, and we'll start. Let's see, get here. Oh, share screen. Okay. That one and share.
There you go.
An animation slideshow. Start
I
from
see a
beginning.
star.
Okay. ZWO SeeStar S50 Smart Telescope by ZWO. Okay. First off, this device does not take images from the internet or AI-generated material and pass them off as images that you have acquired. This device is not a toy. Cube the Lazy Geek certifies this, and so do I. The intent of this device was to make astro imaging more simplistic to a wider audience of users. This device was not created to replace a dedicated astro imaging setup, so relax, breathe, take a breath. Your investments are safe. What's in the box? We have the display unit here. We have a tripod. We have a data cable, and we have the solar filter. So that's the case that comes with it. There's your solar filter, that's Thousand Oaks generated based, and your small carbon fiber tripod. So what makes it tick? So it's quite a little complicated little rig. So what do we got? It's only about 3 kilograms in weight. The size is about 142 by 129 by 257 millimeters. The battery life is approximately 6 hours. The aperture is a 15 millimeter triplet achromatic optic at f5 and a focal length of 250 millimeters. The sensor is an IMX 462 which is quite a small sensor and is getting dated as this point in time. New iterations are coming up with a larger sensor and more modern sensors as well. The image format, we have videos for MP4, we have AVIs, and then we have stills that are TIFF and FIT at resolutions of 1290 by 1080. The Wi-Fi signal is generated by 5G or 2.4G, depending on if you want speed or distance. Temperature ambient from 0 to 40 degrees Celsius, less than 60% relative humidity. Well, I've had that down probably to the minus 15. Relative humidity probably about 45% in the wintertime, and we're still going strong. The mount mode now can do both Alt-Az and EQ mode as well with a new update. The Bayer matrix of the sensor is GRBG, and we have a dual band filter that basically it isolates the O3, oxygen 3, and hydrogen alpha wavelengths, and you see the relative sensitivity and sensor quantum efficiency graph below as to where the sensitivities are that the sensor can capture. So first of all, when you're going to start to install or set it up, you would install the software from the App Store like Android or iOS. You make the network connections with the software to the internet. You power on the unit. You do any software firmware updates in the system once. Follow the software prompts. Essentially, it has a bunch of wizards that you follow. It's pretty straightforward. Then you reconnect to the SeeStar instead of the internet. You level the SeeStar, calibrate the compass, turn on dew heaters, start exploring the software and viewing modes settings. And if you want to save all the images to the SeeStar captures, you should enable it, and more on that later. So the SeeStar is designed for beginners looking to photograph the moon, the sun, and deep sky objects. People who want an easy way to locate and view objects in the night sky using EAA or electronic aided astronomy. People who are interested in astronomy that don't have the time or resources to dive into astrophotography, and people interested in facilitating astronomy outreach and education. That's what the SeeStar is designed for. What is it not designed for? Is people who want to take detailed close-ups of planets such as Jupiter and Saturn and deep sky objects that are dim. Experienced astrophotographers who already have a sophisticated camera and telescope systems, and people who want to construct a custom imaging setup catered to their specific needs. This is not designed for you. So I'm going to start with some pros and some cons. First of all, I know it's counterintuitive, but the SeeStar S50 versus a traditional Astrophoto. Okay, the SeeStar is an all-in-one unit. It is built-in Wi-Fi and Bluetooth connections. We have a low power consumption and a long battery life. You have smart control with mobile apps, and you also have support of a global Astro community within the app itself. Traditional rigs, it's complex setup process. They're heavy to carry and heavy to transport. They can be very expensive. We all know about the rabbit hole about spending stuff on astronomy. Sometimes you can have a steep learning curve, and that's mostly post-processing and setting up gear and calibrations, et cetera, and then time and energy consuming. Cons. The ZWO SeeStar has a narrow field of view, and the sensor is in portrait mode as opposed to landscape orientation. Larger targets are sometimes truncated or less than optimally framed or can be difficult to fit in the frame. The camera orientation is static, cannot be rotated, which also limits the field of view of the sky when framing. You basically are at the mercy of where the object is in the sky when you start to frame it. However, recent developments with the SeeStar software develop framing or mosaic mode, and that will fix that issue, and I'll have more on that later as well. And the SeeStar, again, as I said before, is not designed for planets, as the focal length is quite small, 250 millimeters. You're not going to get a whole lot of detail on a planet surface or anything of that effect, other than the moon or the sun. And lastly, the software and firmware updates can cause more issues than they arise or they address. However, ZWO is quick to respond to fix any bugs that arise following an update, and customer service is actually quite good or exceptional. So the latest and greatest features, since I did this presentation about 10 months ago, and ZWO responded to a lot of concerns. As I had said, the framing and mosaic mode lets you zoom out to get a wider field, and you can actually rotate the field of view. and it does it by mosaic captures of imaging. A new EQ mode was developed. We have now a section where you can do image planning. You can custom object entry as well. They now have increased the exposure time up to 60 seconds, and that's only available in EQ mode. And now you have the ability to shoot flats. Okay, so the first screen you see here is the first screen that you're presented with when you start the app. You have the SeeStar here. This little guy here, if you click on him, it'll open up some settings. So we have stargazing mode, we have solar mode, we have scenery, we get your planning here. We have your deep sky stack, which you can, if you get images that you save, you can stack them here. My album is basically where all of your files are being stored at, and you can go and you can see them. And if you click on Sky Atlas down here, you'll be presented with just that, the Sky Atlas. You can zoom in, you can zoom out, you can search for objects, you can change your grid from azimuth to EQ mode, you can turn on or off the ground, and you can actually go into framing or mosaic mode here. Okay. So if your first thing you need to do when you start the SeeStar is you need to level. So if you go back to this over here, you click on that little picture of the SeeStar, it'll take you to the settings mode. So there you would select advanced features, you would go to calibrate, and then you click on adjust level. Because let's face it, if you don't have it level, you're not going to track properly. And for the interest of this presentation, most of what I'm going to say is for Alt-Az mode. So here we have a newer tripod leveler. If you're going to do EQ mode, or not EQ mode, but Alt-Az mode, you want to have one of these, because otherwise, if you're going to try to level, you're going to try to mess around with tripod legs. This takes the so much more easier to do. So you put the SeeStar on top of this here, and you put this bottom on top of your tripod. And to level it, you use these knobs here to level it one way or the other, and it tilts this place so that you're able to level it quickly. So when you open up the leveling software, you're going to see two circles here with your level. So this one here is displaying this really out of alignment, 2.6, and your circles are separated. Once you get it leveled to a point, and this guy here, whoever it is, he took a lot of time to get 0.0. If you're like about 0.3 to 0.4, it's usually sufficient enough, and you'll go and have green circles. Once you're done, you're finished your alignment, or not alignment, but you're finished your leveling, and you can proceed with the next step, which is compass calibration. So again, if you go back to your SeeStar icon here and you click on that, you go back to compass calibration, you go to advanced features, compass calibration from here, and then another menu will open up and it'll show you an animation. So what this does, it helps the compass know where it's being pointed. So here with the compass calibration, you see the animation. This fellow here, he's basically rotating the tripod, and you have a circle over here that's green, and you'll get a little graph as it goes by. It'll just go around in a circle such that, and when it's ready, the compass is calibrated, you'll get the green check mark. Once you're done with that, you hit complete, and your compass is calibrated. Okay, points to keep in mind. Your stargazing mode, or DSO, plate solving is more important than leveling. Horizontal calibration, like a 3-star alignment, is done when you first start imaging your first object of the night. For solar and lunar mode, leveling and compass calibration is very important because it doesn't plate solve on the sun or the moon. You have to have those pretty much intact. So, as I said, if you want to save all your files captured, which will save them as FIT files for further processing outside of the SeeStar, again, you would go back to your main menu, you would click on that little SeeStar icon, little device icon, you go into advanced features, and then you would go here to say save each frame. So that'll save each frame to your SeeStar in FIT files, and you can copy and paste those to your computer. You can post-process them in Serial, you Pixelcite, whatever program of your choice, and go from there. And I mean process, I don't mean edit, I mean like process. There's a difference. So how do you take a DSO image? Once you're in the Sky Atlas, you can scroll around the atlas and find and frame the object you want to image, or search using the object's icon. Once framed, Press the go to, and the scope will slew to the object and center it by plate solving the object. So you click on your Sky Atlas here, it'll bring up the nice Sky Atlas screen here. You can scroll around in the Sky Atlas and find whatever you want, because your scope is the blue square, your target is going to be the red square. So when you're slewing for a target, you're going to get a red screen or a red box around the ones that you're doing. So when the scope slews to it, you'll see the target and the scope align perfectly. That's you're basically aligned where you want to go, and then your go-to will do that for you. Now, the other way you can do search for objects, if you click on the search objects in the sky map, you can get a list to select from. Once you decide to go to an object, you push the go to, and again, the scope slews to where the object is and center it by plate solving the object. So here, if you go and click on objects here, it'll bring up another, the screen here, it says objects. It'll give you tonight's best. It'll give you deep sky, like with galaxies, nebulae, clusters, SH2, NGC, IC, they're all there. And then you have the options of doing solar system, like your moon, your sun, your planets. And if you want to go ahead and do a search here in this bar here, it'll bring you up another list. Like, for example, if you want to do nebula, it'll bring up your nebula locations here or your different objects. And then you click on your go-to and it slews to your object. And again, with how to take a DSO image, once you're slewed to the location, you'll get your live view screen. You would push on your autofocus button and then select the light pollution filter if needed, but usually it's automatically by object type. So if it's an emission nebula, that light pollution filter should be already enabled, and instead of being black up here, it'll be red. But if it's not, you can toggle it on or off. So then the SeeStar will take 5 dark calibration frames, and then it will proceed to take subs. So you see here, preparing for image enhancement, that's when it's taking dark frames. Once it's done, you'll start seeing the live image being built and the time being done here. So if this is 10 seconds, you'll see 10 seconds, and you'll have a status bar going here for 10 seconds. It'll just keep on going and going and repeat, and building more images to the live stack. Okay, shooting dark frames is important in astrophotography because they help remove things like noise and amp blow from your images, resulting in a cleaner, more detailed deep sky pictures. Noise and amp glow caused by camera sensors and electronics can obscure faint celestial objects. Dark frames can capture this noise pattern, allowing software to subtract it from your light frames or the actual images of the sky during processing. So, again, if we want to do framing in mosaic mode, remember I was saying you're pretty much limited to where it is in the sky? Well, not no more. This is what ZWO did to address that issue. So we have here where the scope is, the blue rectangle is where the scope is basically pointed. The red is where your frame is now, because your blue is your native resolution of the scope. The red at 2.7x out gives you that much more field. And also, if you wanted to frame this differently, like if your nebula or your cluster or your galaxy was pointed in one direction or another, you can rearm this here, or you can reposition that. Like he's got it positioned here at 16 degrees. So 16 degrees from being top dead center, he's rotated that off. So if you look at something like the Andromeda Galaxy, really large. So your blue screen is your native resolution of the scope. Now we got a target that takes in the entire galaxy. Both, one positioned, rotated to where you want it to be, and the scope is the blue. So what happens is the scope shoots a bunch of photos and live stacks it into something like this. Now, these black areas here will eventually be all filled in by data, but this is just an incomplete image. So this lets you know, this shows you that you're no longer limited to the blue square, which if you rotated it one way or the other, you'd only get that much of the galaxy, and you would get it orientated in that fashion, portrait. If it's rotated differently in the sky, you'll get a different image. But the framing mode gets rid of that and lets you frame your photos that you want to do. It gives you more flexibility, basically. EQ mode. A wedge will be needed or a tripod that you can mount the SeeStar onto to be able to adjust altitude and azimuth. So you get something here like an Ioptron wedge or the Williams optic wedge. You want to basically put it on the wedge at your altitude that you're on and make sure your control panel, or I'll get back to that later, put it on your tripod, put your center of gravity over top of one of your tripod legs. So I'll just show you here. So as you see, the control panel is facing upwards directly towards you, and the wedge is positioned over top of a north-facing tripod leg, such that the weight of the SeeStar is being supported by that tripod leg to avoiding a tipping event. Because if you put that over top of where there's no legs, where there's a space, and you're starting to move, or you get a little bit of wind, well, it's not going to be a good thing, I don't think. So this is what ZWO was recommending. It makes sense. Okay, so how do we get to EQ mode? Again, if we go to the SeeStar app and we see the main photo here at the front of the main menu, we would go again to advanced features, and then we'd go to mount mode, which is Alt-Az mode, and you can toggle that back and forth between Alt-Az and EQ. Once you're into that screen, you'll have basically the software will tell you where the current latitude is and where the degree is that you're looking at. Okay, so once changed to EQ mode, adjust the altitude on the wedge to match your altitude display on the current altitude area. So we're approximately 45 degrees. It gives you a rough polar alignment. Once the altitude is adjusted, click on polar aligned deviation down here. Okay, so we've got the altitude set at 45 degrees. Okay, well, is our azimuth and altitude still right? Well, this is what get polar deviation does. So the app will then tell you how much and what direction you need to adjust the altitude and azimuth to get a precise polar alignment. Typically, if you get the green check mark, you are good to go. I always try and get the numbers as close to 0 as I can. To get back to the previous menu, click on the back arrow, the top left of the screen here. If you want to get back to the Alt-Az mode, click on Switch. Actually, I've done that in error, and I went back to Alt-Az when I wanted to be in EQ, but this is something that needs to be addressed, and something like an OK button or whatever will be here and when the alignment is complete. Once back to the same menu, use the scope as you normally would. Now, I tried polar alignment last night, and I found even just after doing this once, it wasn't sufficient because I was still getting trails. So what I would have to do is I would have to do refresh align deviation. And I did that probably about 3 or 4 times before I got a really good alignment in that area. And it worked better, after I did that. So using 60-second frames in EQ mode, again, go back to your main menu, go into advanced features. And if you're in EQ mode, it gives you the option to go and do 60-second frames. This feature here is a bit problematic because the software is not properly optimized yet for some reason or other. But you got to think, well, it's not really designed to do 60 seconds, I don't think myself. 20, 10, 20, 30, yes. But 60 is really pushing the limits of what the scope can do. Anyways, it's there. Planning a session. So from the main menu again, we saw that plan icon. So if we click that and we do create a plan, we enter its name that we want to call it. We can either search for objects or we can go into the Sky Atlas and look for them. And then we can do a little icon down here, the little planner or a little calendar. We press on that and you can add that to it. And then we can check and drag whatever time we want to image that object. And then we can add more as we want to go throughout the night. And it gives you the altitude of the object as it is in the sky as it rises and falls. Gives you the type of your object down here. But anyways, you can add more as you go and then click your check mark to start. And then once you're starting, you say okay, and away you go. And it'll give you your status up here as to where you're shooting. And you can also stop it if you need to for whatever reason. Custom object entry, easy peasy. Go into your Sky Atlas or search your objects. And then once you're into the objects, you go for my favorites of more. So there's a couple options. You can either customize it directly by knowing the name or whatever you want to call it, typing in your right ascension and declination, and go ahead and say add, or you can use the current position of your SeeStar where you're pointing towards it on the sky atlas. And that'll fill in all this information for you, and then you click add. And then once you've done that, you'll see created successfully okay. And then to access that, you go back into your objects and it's under my favorites. And you can select that as you go. And again, you do the same thing as you would do a go-to. Shooting flats. The purpose of shooting flat frames in astrophotography is mainly to help remove unwanted artifacts from images like vignetting, darkening around the edges, that's what that is, and dust spots, etc., resulting in cleaner, more detailed final images. So again, go back to your main menu, go into the advanced features, go and scroll down to your image calibration, and then flat shoot. And then what happens then, you take a point and you point the unit away from a direct sunlight and cover the unit with a white t-shirt, or you can use a piece of paper or a light panel, tablet, etc. If the flat image is acceptable and successful, you get a flat image that is used with every image you take. And this little tells you what, again, there's a wizard that you can follow. And to move it away from direct light source, you can use your little joystick down here. Press your shoot. It'll do not move the flat panel when shooting. Stop shooting does not save the flat file. And then once, if it's successful, you'll do flat shoot succeeded, and hit OK. And then that applies that to every image that you take. Unless you want to do a different one, you can reshoot it, get a better flat or different flat depending on your light conditions. Okay, there are oodles of YouTube videos about the SeeStar and astrophotography on each mode the SeeStar has. Okay, future enhancement ideas would be maybe to add a size and magnitude to objects, renaming the stargazing to DSO, referring enhancing as stacking, rename ground to horizon on the sky atlas, change currently invisible to below horizon when describing objects, larger aperture. Okay, there's an S70 that's currently being developed, a faster F ratio, have a camera that has a larger sensor, which is currently in the works and available soon as a SeeStar Pro S30, pre-orders in June. So what do images look like captured by the SeeStar S50? Well, here's an image of the Iris Nebula, stargazing mode or DSO mode. So unprocessed, yep, you're going to get some field rotation. You're going to get some star trails, not so much star trails, but satellite trails. Hello, Elon Musk, thank you very much. Then you have your processed image that I usually do by third-party software. You can also do this by your SeeStar stack, but I find third-party processing is a lot better. You get more control and fine-tune things differently. Okay, again, Lagoon Nebula, processed versus unprocessed, right? This is the unprocessed ones are things that you're going to see as a live stack on your cell phone or either on your iPad or whatever device that you're using. And see again down here, you've got some satellite trails. You don't get as much detail here. The stacking process removes the satellite trails and you get more detail. And again, unprocessed of the Cygnus wall, you get just one hydrogen alpha, or you can get, I can just do the Hubble palette with it. Again, with the Western Veil, unprocessed. Unprocessed here doesn't actually look too bad, but you can get more definition. Yeah, I can reduce the amount of stars to get more nebulosity, more apparent. And then again with the Hubble palette, false Hubble palette. And then like with a galaxy, again, I've got a lot of satellite trails and I got field rotation. I can crop that out. I can process it with third party and I can make things look a lot better than what they would here. And same as solar mode. One on here, this is raw captured through the SeeStar. And if I take this like in a program like AutoStacker and IMPPG, Photoshop, bring out the details, enhance contrast, sharpness to get something that's processed over here, totally, white light photography. And then for lunar, this is basically a daytime moonshot that I did. And again, with the AutoStacker and IMPPG, Once you get ion PPG, it converts to monochrome, but you can bring in a lot of detail on the lunar surface that you can't see here that is actually in your data when you see it, when you stack it. And some just the beginnings of my gallery. These are all images that were taken by the SeeStar and third-party processed using serial scripts from Astro Barbecue. Anyways, there's a lot you can do with it. So again, we have the Rosette, we have M45, the Pleiades, we have the Bode's Galaxy and the Cigar Galaxy. And I know the name of this comet, but I can't figure out how you say it. But anyways, that was taken over early spring. Monkey Head Nebula, the Horsehead Nebula complex with flame, the heart of the Heart Nebula, and then we have the Swan Nebula or the Mega Nebula, Trifid, Helix, M33, and I think that's M Messier Object 3 for the globular cluster. And then the Orion Nebula and more solar, Wizard Nebula down here. And then just a bit of shout outs of the owners that I know personally that have SeeStars. And I just want to mention them: Alexa Wilcox, Joey and Haley Croswell, Pat Bacon, Chris Benoit, Kathy Keith, David Smard, Jennifer Day Elgie, Stefan Picard, Rob Carson, Mark Fitkin, and Kathy Adams had a SeeStar. She migrated to the Dwarf 3, and I believe Chris picked up that SeeStar from her, and he's quite happy with it. So thanks, guys. You're making the SeeStar look really well. And also, I have a group of my own, the Charlotte County NB Astronomy Group. We started off with 15 members. We're up to 61 now. It's a small controlled group that basically people in my area or general friends on my Facebook account that's interested in this site. It's open to all avenues of discussion, not so much limited to SeeStar or smart telescopes. It's like example, we have David Simard here. He's got a lot of good imaging here coming from, he's doing remarkably well. Chris Benoit as well. He's really enjoying his SeeStar. Alexa Wilcox, she's a local down here. She bought a SeeStar just recently after talking to me not long ago because she was wowed by it. Joey and Haley Croswell, they introduced me to the SeeStar. And Joey's been a good friend all my life. And Kathy Adams, again, she's, I think everybody knows Kathy. She had the SeeStar before she went to the Dwarf 3, but Kathy's been a good friend of mine as well for many, many years. And yeah, so yeah. And where are we? How far have we come? Well, picture of mine with the Rosette Nebula when I first started, and I'm up to this, location here now. And David, he again, I can't explain how much more he's, doing with his imaging. So we have come a long way in our acquisitions and processing on the group, and I'm very proud of you all, guys. Well done. So some of the references I have was Q the Lazy Geek on the YouTube channel, serial homepage and downloads, processing SeeStar data in serial, using serial with Astro Barbecue Hubble scripts by Alan Burgess, and then his channel with Deep Sky Shed. And then we have the ZWO SeeStar support at that location there. Comments and questions, and thank you so much, guys. And I hope everyone enjoys their smart scope of the SeeStar and others. Okay, that's
awesome.
all I have.
Awesome. Thanks very much. Okay, I got one question here.
Yeah.
From Mark Fick, and Mark says, did Robert do the last update and have trouble with the EQ mode? Kyle and I had trouble with the deviation, especially using 60 seconds.
Yeah, I did the last update, and I think it's something that they're going to have to work on, to get tracking down better.
Yeah.
I don't know, like 60 seconds for something that's not that really sophisticated piece of equipment. Basically was designed to do Alt-Az mode to begin with. They just added this to see what they could do. And, with Alt-Az, the original exposure time lengths were anywhere from 10 to 20 to 30 seconds.
Yeah.
A lot of people were using just 10 seconds for Alt-Az mode to begin with, because that's where you get your least drop frames. I know with the fact when you're doing anything like 60 seconds, even with polar mode, even with using a star tracker that I use with the camera, I still get a bit of star rotation. So I'm thinking this is something that ZWO will have to work on eventually to get more refined tracking for their for the EQ mode at 60 seconds. But for me last night, I used 20 seconds, and that seemed to be the sweet spot.
Awesome. Okay, thank you. Yeah, so lots of information to pick up there. And of course, the videos back up. Don't rely on Facebook because Facebook takes the video down after a month now. All my videos from the last number of years, all of our, for the last 5 years, have all been gone. They're deleted. So the only place you're going to find our videos now is on YouTube. So just go over to YouTube. You'll find every one that we've ever done with it. Don't look at the first few. Anyway, work your way down. But Robert's presentation will be there because there is a whole lot of information there to absorb for sure. Thank you, Robert.
You know, and please feel free if you want to message me anything or any questions or whatnot. You know, I'm on Facebook, so look me up.
Awesome.
And if you want to become a contact or whatever, I can add you as a contact, and I can add you to our group if you're interested.
Great. Thank you so much for the presentation. Okay.
Thank you.
All right. Mike, do you want to come up with the final bud?
Not after that.
Sure you do.
Wow. Well done, Robert.
Thank you.
Well done, Robert. Yes. Okay.
All righty. This should be the right one. Binocular target of the week this week by Bono Bud is the backward 5. Yeah, you've seen it before, and you're going to see it again. The Astra is a backward 5. Looks like what you may have guessed, a backward 5, or some see it as the letter S. It's easily seen and located near Zeta Hercules. And in the center of the field of view of binoculars, you will look up and see a backward 5, depending on your orientation to it, or the letter S. How do I find it in the sky? Well, tonight at 2300 hours and it's nice and clear, you may have an opportunity if the moon doesn't wash it out, but to orient yourself 120 degrees or basically almost straight up. And you will see the Keystone Hercules and this bottom star in the corner. It's just off to the right-hand side of it. It's right in this area right in here. You can't miss it once you get a pair of binoculars on it. A little closer look. It's right here. And there it is. Starting with this star, comes down number 5. So it's actually there, and it looks like the number 5 or the letter S, depending on the orientation. Here's a photo of it. Look at that. Stands right out as the number 5. You can't miss it. So it's pretty cool. You're not going to see those colors through a pair of binoculars, but there's that bright star Zeta Hercules there. You just come down from it, and you'll see the number 5 in the sky. 10 by 50 binoculars. It's a fair size. Where did I stick it in here? Where's Zeta? I know it's here somewhere. Hard to see on these Stellaria maps, but it's just come down in the corner. It's right in here, so you won't miss it. Compared to the full moon, well, it's got to be at least 2 full moons. So, you know, one full moon for each of the curves. So it's a relatively easy target once you get a pair of binoculars up on it. Easier than Stellarium maps. Are you ready? Here we go. Why do astronauts use Linux? Because you can't open Windows in space.
Oh, gee.
That's our target of the week by Bono Bud.
Yeah, that was a rough one.
Well, you can't.
You're true.
Simple as that.
Chris wants to know, do any of those YouTube videos give us any background on the insider Cygnus joke? No.
No, that's a secret.
That's a secret, that one, yeah.
You gotta have the key to get into that little.
Join us at a star party, and if you're joining us at 3 o'clock in the morning, we're having a cup of coffee. You can probably tell us. We'll probably tell you that.
It'll be revealed at the star party.
At the star party, yeah. Okay, awesome. And let's go with that, Paul. We're going to go to Rosanna's fun fact next.
All right, let's see if we can make it work for number 1.
Yay!
All right, here we go. And this is this week's
Rosanna's Fun Fact.
Hey, welcome back, Rosanna, with another absolutely fun fact. So let's get right into it. So Rosanna writes, hi, Paul. As spring creeps ever closer to the official first day of summer, a lot of the neighborhood talk is about the birds, the bees, and mostly about the sun. Humans smile more on a sunny day. Last year and this year, solar astronomers have even more to grin about. Now, let me just see if I can't make the pictures work here. There we go. So, as spring creeps, excuse me, losing my ability to speak. Scientists now feel we are heading towards solar maximum sometime in July, although true maximum could happen anytime between October 2024 and November 2026. Back in August through September 2024, the highest ever amount of sunspots was reached with an average of 215.5 per day being recorded. That's a lot of sunspots. And to add to this excitement, the ESA's solar orbiter has now come within 42 million miles of the sun and is giving us new views of the sun's north and south poles. The solar orbiter is not the first spacecraft to image the sun poles. The ESA from NASA, Ulysses, spacecrafts observed the North Pole in 1994 and the South Pole in 1995, but Ulysses was 200 million kilometers away from the sun. The solar orbiter can get so much closer because it isn't traveling on the ecliptic as most spacecraft do. So what makes the poles of our star so interesting? So scientists are eager to get closer at the sun's poles because they hold vital clues to the sun's behavior. Our star follows at an 11-year cycle called solar magnetic activity cycle, during which its activity peaks and then subsides. During solar maximum, more sunspots appear and the sun produces more storms. Since these storms affect Earth, think auroras and interrupted communication systems, scientists want to know how the cycle works and how they can predict powerful storms. So this gentleman here, Sami Solanki, is the principal investigator of the solar orbiter's polyometric and helioseismic imager, or the PHI, one of the spacecraft's 10 instruments. Solansky, also a director of the Max Planck Institute for Solar System Research in Germany, states, "We didn't know what exactly to expect from these first observations. The sun's poles are literally terra incognita. The PHI captured this image," and that's the image that it captured. Now the blue areas indicate a positive magnetic field, and the red indicate a negative magnetic field. Now, the sun's magnetic fields are far more complex than Earth's. They appear to be in a constant state of turmoil. Outside of the poles, the sun features many small, complex magnetic structures that vary over time. These structures occur in connection with other features like sunspots and generate the star's large-scale magnetic field. During most of the solar cycle, the large-scale magnetic field resembles a bar magnet, with the sun's geographic poles lined up with the magnetic poles. During the solar maximum, the sun's magnetic poles reverse. The solar orbiter arrives in just the right spot at just the right time to give us new and amazing views. The collage that you see here shows the solar orbiter's view of the sun's south pole on 16th and 17th of March 2025 from a viewing angle of around 15 degrees below the solar equator. The data is from the polyometric and the helioseismic imager, or PHI, the extreme ultraviolet imager, the spectral imaging, and the coronal environment instrument. PHI captures the visible light sent out by iron particles, which is the top left one, and revealing the sun's surface, or photosphere. As previously shown, PHI also maps the sun's surface magnetic field along the spacecraft's line of sight, which is the one in the top center. EUI images the sun in ultraviolet light, which is the top right, revealing that million-degree charged gas in the sun's outer atmosphere, the corona. The SPICE instrument is various wavelengths, which is on the bottom row, captures light coming from different layers above the sun's surface. So from the chromosphere right above the sun's surface all the way to the sun's corona. I kind of want this image as a poster. Now I'm going to show you the next photo. After another flyby of Venus in December 2026, the solar orbiter will be able to get even better views of the sun's poles from a 23-degree angle. The Earth's magnetic field may not be as complex as the sun, but we do have something going on here as well. We have the South Atlantic anomaly. Now, the bulk of the Earth's magnetic field originates deep within its core, at the boundary between the molten outer core and the solid mantle. The magnetic field extends past the surface into space, and acts like a protective shield around the planet, repelling and trapping charged particles from the sun. But over South America and the southern Atlantic Ocean, an unusually weak spot in the field called the South Atlantic Anomaly, or the SAA, allows these particles to dip much closer to the surface. NASA released a concerned statement about the weakening status of the SAA at the end of May. There we go. So NASA's concerns over the geometric phenomenon are as fascinating as they are worrying. The SAA is an immense region. The weakening of this area, far from being a mere scientific curiosity, acts as a breach in our natural protective shield, allowing high-energy solar particles to come dangerously close to the Earth's surface. Particle radiation in the SAA can knock out onboard computers and interfere with the data collected of satellites that pass through it. Some satellites pass through the SAA 8 times a day. So think perhaps a Death Star vulnerability in reverse. So whether you are suntanning while reading about satellites skipping through the Earth's SAA, or sketching sunspots by gazing through your solar scope, or hoping for a solar flare to storm to create an evening aurora, our sun truly is the star of the summer season. Can I plug in my extension cord over here? No. Why? Solar flares. A large solar flare could dent the Earth's magnetic field inward. The Earth's spin could then induce a strong current in any long conductors, melting them and starting fires. By extending your power cord, you will kill us all. Really? Warn your friends. That was mean. Listen, somebody has to keep the Mythbusters in business. Next season should be fun. And that's this week's
Rosanna's Fun Fact.
And as usual, it is an absolutely fun fact indeed. So thank you so much, Rosanna, for that great information, and to bring on the sunny weather that we're all going to just go sit back and bask in that sun, and we don't care what's going on because we just want to enjoy warmer weather and clearer skies.
Very enlightening.
Hey, I'm back. Yeah, thank you. True enough. Yeah, summer skies are awesome, and well, dark skies are nice too, though. But that's coming too. So,
Yeah.
Okay, let's get quickly to some photos. Thank you, Rosanna, for that informative always.
Indeed.
Okay, we'll get to some photos here really quickly because I know we're running a little bit late. Let's go to this one. I think we're okay. All right.
Or the deer running antelope play. Selling her. Oh, you're back? Okay. Oh, very nice. That's going to be Francois.
Okay, so we got Francois Theriault. Francois said this is the last picture he's going to send in for a few weeks. He's going to take some time off, I guess. So this is his Tulip Nebula in Cygnus.
Very nice. What's that, Chris? Where is it at?
It's somewhere in the sky. I don't know. It doesn't really matter. It's all about the nebula, isn't it, Paul? It's all about nebulosity, isn't it, Paul?
It is.
It's all
Especially
about Yeah. Okay. Anyway, let's go on to the next picture. Thank you, though, Francois.
Very nice.
Very nice. Great job. This one's coming from Clayton Carr. Of course, we had the strawberry moon the other night. lots of fire smoke that was in the air, causing this orangey color. Really low moon, lowest moon now till 2043 apparently. We'll see the next one or not. Anyway, but low moon and lots of fire smoke led to these really orangey type of moon rises, and got lots of captures on that, including these ones from Clayton Carr. Thank you, Clayton. We got this one from Jill and Reed. Judith Rees sent in these ones.
Nice.
I love that color, eh?
Yeah.
Oh, spectacular.
Robin Diane LePage sent this one in. And this one.
That looks like a pink strawberry moon. That was nice.
That's that
Baby
one.
orange.
That one there as well.
Very nice.
Diane. I'm going to move on to Bonnie Lee. I know I'm going through these fairly quickly, but we're a little bit on time. So Bonnie Lee sent this one. She said just after moonrise on over Waterside Beach. This is one of these. It was crazy red. She said the lobster boats were lined up waiting for high tide to head into Elma.
Yes, sir.
The other one from her as well. Thank you, Bonnie. Jean-Guy Boulet sent this one in.
Let's see.
It appeared normal at 11:30 p.m. from Quispam, but it was showing off in full spectrum. You can see the smoky haze as well. You sure can.
Yeah.
That's neat.
Done, Jean-Guy. Thanks for that.
I think it just added to the flavor that night, though.
Yeah, it did for sure. Amy Price from Indian Mountain. Nice shot, Amy.
Very nice.
And Margaret McCarthy is up next. This one. Well done, Margaret.
Yeah.
Love the reflection.
Nice reflection, eh?
Where's that? Did she say?
She didn't say no.
Okay.
Tara Hart. Put this one in. Thanks, Tara.
Nice.
Laura Butler. Well, hang on a second. This is Deborah Free. Sorry. Nicely done. And this is Laura Butler's through binoculars.
Oh yeah, looking that cool. Eh?
Cool.
Another one here from Pamela McCluskey Hollis at the Res in St. John.
Pretty
All
fun.
great shots. Thanks, everybody. Great shots. I'm going to go from there now to this one from Jeff Pendlebury. Jeff says, moonset at Victoria Park in Charlottetown, PEI. Thursday, June 12th. So that was at moonset. So nicely done, Jeff.
It's very nice.
Here's one from Lisa Rob Show. Awesome, Lisa. And another one here from Shannon Lee. Boy, lots of pictures. Everybody, I love this fact that people are sending these all in to me. Like this. Shannon Lee again. And Carol Beans captured the moon rising last night, she said, or taken from St. Stephen's.
Yeah, it was a spectacular sight. It was nice to see lots of people getting out to capture it.
Yeah, there was like 20 cars or so at the beach, eh?
Oh, easy. Yeah, there were 3 rows.
Yeah, they were down at the other end of the beach too, so quite a few there. Barbara McKinnon sent this one, beautiful, just outside of Fredericton, she says.
Yeah.
Nicely done, Barbara. Go on from that one to Trish Ron here. Trisha Ron, nice shot, Trisha.
All those shots across the water.
Look at the old reflection there. Barbara Baird sent this one. She said the strawberry moon, she said, hadn't ripened yet locally. Moon finally rose over the trees in Charlottetown. There you go. Nice. Irene Doyle says, for us, last night was the moon, but tonight it's the sun. Those western fires, smoke is really helping. Look at the sunspots, eh?
Yeah. Down the bottom.
Nicely done there, Irene. And Eliza McGrath by Saints Rest Beach. She said it was amazing to see her come up over the horizon. Nicely done, Eliza. And this one's from Jocelyn Good Lawrence. Hey, Jocelyn, just peeking up over the top there, the trees. And that's all the moon shots I got. I think I've got a couple more here a little further down. But anyway, this is from David Samard last night, M31 with 2 exposures. Actually, I only got the 1 shot. Maybe I got the 2. One 10-second shot and the other 20-second. The image was not processed. He said, so it's that one. And yeah, there's the other one.
Okay.
Going through that one.
Satellites everywhere.
Yeah, I won't tell you, it's pretty crazy.
The little galaxies, though. If you look down to the bottom right,
Yeah,
there's
running here. Yeah. Yes, sir.
one right above it too.
We love it there too. Yeah. Crazy. Nicely done.
Period.
They're everywhere.
They are.
David.
Oh, Paul,
Gary sent this one in. Brad says, hi, Chris. Just sharing a couple of captures for the past week. The first is of the full moon rising on Wednesday on the 11th, Fredericton.
yes, sir.
Shot. He always sets up a nice shot.
Yeah.
This one's from
That's
Aurora.
cool.
The fireflies.
Yeah, he said this second photo was from Aurora on Thursday the 12th, taken at Durham Bridge and with the field of fireflies. The fireflies were captured repeatedly while waiting for the aurora to kick off, and then stacked and combined with the sky once the aurora got going. The
Yeah,
fireflies.
look at the star definition too.
Yeah, always. The fireflies always mark the beginning of summer, Brian. So cool.
There's fireflies or Starlink wannabes.
Yeah, yeah, exactly.
Cool shot. Thanks,
Very
Brad.
Yeah.
Where am I at now? Oh yeah.
It's the IFF.
This is from Mr. Powell. Tell us a bit about that one, Mike.
You shouldn't have put that one up there.
Why not?
Uh,
Tell us a bit about that. Look at the stars. Holy mackerel.
Well, it's quite an area from stars, that area that we don't talk about.
Right, yeah.
Right up the Milky
Cygnus.
Way.
Yeah.
The-
Too bad. There's lots of stars. It's a nice area of sky, really. Too bad it's there. But anyway.
All the smoke
Cygnus, eh?
Yes, Sagittarius is nice too, though.
up in there somewhere, yeah.
Okay. Yeah, beautiful shot though, Mike.
So that's the Vale complex, eh, Mike?
Yeah.
So what's in it? You got the Eastern Vale, the Western Vale, Pickering's Triangle.
Yeah, I'll go with that. It's pretty.
Oh, it's nice that you got something so wide because most people only get portions of that. They either get the Western or the Eastern or the Triangle, but you got all of it with that wide scope, man. That's pretty cool.
For those that don't know, this is a supernova remnant. That's what we're seeing here. It's the remnant of a supernova. Awesome
That
shot.
played nicely. I didn't have to rotate the camera either. So
Yeah. No, nicely done.
Yeah, very nice.
And this one, Mr. Owen.
That was this morning at 5 o'clock.
5 o'clock this morning. Yes, sir. See, it does pay to get up early.
Yeah, and there's Blue Heron coming in.
That's
didn't know he's
that's
blue.
quite a shot.
First
Yeah, I didn't know he's blue.
Black Heron in there, but
there you go.
coming in for the first meal of the day. And you hear those things. It's funny. At that time of the morning, it's so quiet, right?
Yeah.
These guys come in, they make this really cool honking sound, if you've ever heard one.
Yeah.
Mike, you've probably heard them before, have you?
Oh yeah, but not at 5 a.m.
Oh, no. Well, they sound the same throughout the day, but anyway, it's just this really interesting sound they make, and then all of a sudden, you're looking at this beautiful color palette, and it's just so quiet and so surreal, right?
Yeah. Nicely done, though.
Said, you're just getting up to take those shots. I'm just going to bed after taking shots.
Yeah. And if you have any photos to share, we love sharing them. Send them in here to astronomybythebay@gmail.com. 2 more weeks to share them. So, and then I'm going to skip on here to Lisa's Lookup, Astronomy and More. I didn't really put together what's up per se, but this is Lisa's chart. We're going to go to this week here, right? So we Mare Orientale visible on the moon. Look for Neptune near Saturn. Last quarter moons this week, and the summer solstice, of course, is this week as well.
Yeah.
So if you want more information about that, you can go to you can follow Lisa at Ruby Moonbeams on Instagram, Mastodon, Facebook, Threads, and now on Blue Sky. Lisa's Lookup, Astronomy and More, and you can download this particular chart right from there. Thank you, Lisa. Also, too, we have our June-July calendar up. You can download this at sjastronomy.ca. Kurt Nason puts this together for us, of course. Here's this week's schedule. Mars near Regulus tomorrow night. Rask Zoom meeting on Tuesday night, where Robert is going to present his talk again. And of course, the summer solstice is coming up at the end of the week. So, again, you can find us at sjastronomy.ca. And one final thing, we don't mention her enough. This is Rosanna. Rosanna does have a channel on YouTube. Rosart Sky. Was it Rosart Sky or Rosart Ski? But I'll say Rosart. Right? Rosartsky. Okay, Rosartsky Studio. There we go. She's on YouTube, and all of the videos all of the fun facts that she puts out are available there later. So if you want to catch this week's fun fact, you can actually go back and I think by tomorrow or whatever, she has them up on the page as well. So find her at Rosartsky Studio.
Oh, by the way, just so people who are in the area, if you go to the Brunswick Square, they have an art gallery up there. Rosanna's also a painter. That's where the art part comes in from Rosartsky. And she does amazing paintings. And I was there yesterday and I had a look at some of her work. So if you're in Brunswick Square, go on up to the second floor where they have their the paintings displayed, and go down and check out Rosanna's stuff. It's really, really nice.
Awesome. All right. That's everything, I guess, for tonight. Right we're gonna hang on a second. I see a couple of things ready here so I can sign off properly. Close that one. I'll close that one, and I'll get this one up here. Talk amongst yourselves. You guys know, you're like, okay, this is a production.
Close that one. Close.
Fine, put things together.
And then there's just one here. Close that one. Close that one.
All right. Yeah. Anyway, okay. So that's our show for this evening.
One of these things is
I hope you
not.
enjoyed the program tonight. Now 2 more shows. 2 more programs until we take a break for the summer.
Don't you think we need a break?
Hmm?
Don't you think we need a break?
I think we do. Yeah. I think I need a break from you guys for sure. There's no question.
You know, you're going to be hanging out with us.
Maybe. We'll see. Anyway, that is our show for this evening. Special thanks goes out to Robert Gaudet for helping us understand the smart scope. Thank you, Robert.
Nice job, Robert.
Appreciate you for coming in, and hope to see you back again on our show program. We'll see you at the Star Party this summer anyway, sure. But
Hopefully. Yes.
don't forget you can follow Charlotte County Astronomy. Is that right? Charlotte County Astronomy?
Charlotte County and the Astronomy. Yeah.
The Astronomy. Thank you. Okay. Special thanks too goes out to Rosanna again, of course, for her another interesting Rosanna's fun fact. Thank you, Rosanna. And special thanks too goes out to all of you who share our program with your friends and family. And do remember that we do love getting your photos, so send them into astronomybythebay@gmail.com, and we'll be happy to put them up on the next broadcast. So until next week, everybody, wishing you all clear skies. As we like to say, guys, open your eyes to view the skies and keep your scopes. Hold it up. Good night, everybody. Have a great week.